Hey, what's up, dudes? Okay, we're setting the timer. Oh, bro. The fatigue from this project. Well, I don't even think it's fatigue from this project. I just have fatigue. Life fatigue, you know what I mean? Like everybody has. Oh, man. Always some shit, huh? Okay, so it's 5:22 on a fucking Friday, and this is what we're doing. Oh, alright, because, I don't even remember that I coded yesterday. Yesterday was not a good day for me. But, you know, life goes on. Blah, 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 you know how it is. You hear me? The boys escaped through a hole in the prison. Damn. Well, it is what it is, right? Okay, there we go. I didn't check the audio, but I mean, I'm pretty sure the audio is working. It should be. So yeah, yesterday we did an hour and a half. We are finalizing the save logic, save load logic in the save logic file, and we worked with the master list relative to how save load logic will interact with the specifics of each data point entry. We finalized the form of save logic master save object list, identifying which file object each data point is associated with, and it made first pass on final form of save load logic related to this list. We stopped at line 11 and things to do, so that's what we're going to do. We're going to go over here to blah blah blah. Shh, Vegeta. Shh. Oh yeah. Okay, so the deal is, we have to. We are trying to figure out a way to. We're trying to figure out a way to designate. Oh yeah, and we actually figured that out, right? Which object is associated with the ones that need to be like P1, P2 versus data points that are only connected to one object. So we have the both for P1, P2, and then associated is just if you're client 1, that refers like you're only going to save data associated with P1 game in that instance. You don't care about P2 game data because client side doesn't need P2 game data. So the way that we're going to differentiate in that save list is by checking during loading whether the object name has a dot inside of it, basically. So if there is a dot, that means it refers to a data point that is referred to by two different associated objects. Yeah, so I think like that makes sense because the way that we have to save these objects is in terms of P1 and P2, because like you can't have two entries with the same object name. Obviously, you couldn't just use name because you have to have two names. So one would overwrite the other. So we do have to have P1 dot or P2 dot to differentiate. So basically, we're just gonna check to see if there's a dot at the in it at all, because we don't use like dots in the name. So if there's a period in the name, then that means it's associated with two different objects, and that will make it to where whenever we whenever we go to save it, well, it's going to be both for saving and loading, I think. because whenever we save, this is the object name that's going to be associated with the card group dictionary data. So in the database, there's a bunch of rows. The rows are consisting of 2 fields. One of them is the object name, and the other one is the data associated with the object name. So yeah, we have, this is the object name, this string. This is literally like the namespace that we're going to use to save the data into the database. What the fuck is this? Is this? Okay, I don't know. I don't know if that's copyrighted. I hope it's not. It's in my no copyright thing, so it shouldn't be. So for instance, whenever we saved the change attribute list C1 apply counter, it's going to be saved under that namespace. So whenever we load it, we're going to be using the same list to load everything from. Well, actually, we're going to be loading directly from the database, but the database is basically just a reflection of this list with the data added to it, attached to it. So let's think about this. Whenever we load in the data, we're going to need to, we're going to need to know what how to assign this. For instance, we're going to be loading things from the client file. But if we're in the client file, we can't just simply say C1 apply counter equals the data associated with C1 apply counter from the database, because the actual object C1 apply counter that we're trying to handle is technically from a changed attribute list. Now, if maybe we could just do it directly like that, because let's look at client here. Oh, it's already open. So let's check out client and let's look for C1 apply counter and see how does this actually work here. We're gonna check this out. So we have so we're iterating through the received change attribute list here. And the C1, where does the C1 apply counter come from? Let's see. So we have the apply counter, isn't that what gets sent? Let's see here. C1 apply counter, C2 apply counter for above line reference. The tube is equal to timestamp dir string, adder name data, C1 apply counter, and C2. Yeah, so this is what gets attached whenever we go to send something. Let me look here and see. C1 apply counter. There we go. We're gonna have to look throughout. Okay, so here's where it exists originally. And don't we import it? So I'm trying to think of how this would work whenever we go to handle this data, this C1 apply counter or the C2 apply counter. How do we actually like load it? Like where do we load it to? You know, because we're loading it from client, but if we're in the client file, I don't think we can refer to it as just C1 apply counter. We have to refer to it otherwise. And I'm looking at this and I'm like, do we actually need to save this? Well, maybe we would have to load this in from the change attribute list file instead of loading it in from the client file, because we did add it to the list of objects that needs to be saved. So I'm assuming that I correctly assessed that and that we do actually need to save this. But the question is, I don't think we could necessarily save it from the context of client Pi. We would have to like save it from a different, from here, or load it rather. We'd have to, I thought we like imported it or something though. I think what we actually do is we import the data transfer function, which uses the global apply counter. But the global apply counter is actually only global in changed attribute list. It's not like a global in the client file. So if we loaded in that data in client Pi, which is where like ideally it would all just be loaded into the client file, that would create a new object in client called the C1 apply counter that wouldn't actually like change this apply counter in change attribute list, which actually does need to be is what needs to be done. I think we can though, because we do the same thing with SS or CS, right? Like SS or CS is a global in this file, but we import it into other files by, see, we refer to it as change attribute list dot SS or CS. So that will, because I know I tested all this, it properly refers to the actual object, this SS or CS global, in the change attribute list file. So what we could do, which I guess we don't do that, would be we could import it just like we import SS or CS, like this. Well, rather, we import the file, and we say for modifying the actual SS or CS and change attribute list Pi client ID global vars for the purpose of correct apply counter logic and change attribute list Pi functions. So technically, we have already imported the entire file into client. So whenever we loaded it, we would just have to load it in the context of like in the namespace, we would have to use change attribute list dot C1 apply counter. Yeah, and that would change this, like it would change this global, which would in turn change this global. I want to say we tested all this. Yeah, we did. We tested this. That's why we have our double stamp of approval and stuff. Let's see. I have some notes here. Let's see. This extension tells me. We finished converting all logic data structures associated with apply counter. Began to finish converting all logic expect counters. Began running game tests to see the effect of recent changes. Encountered some bug needs fixing. Logged bugs. Reviewed logic in progression associated with valid blah blah blah. Almost found the root cause of the bug. Wait, where'd it go? There it is. Okay, we need to see the rest of this. Can't pass this arg since can't modify original immutable like we need to. Can't. Okay, so we can't pass it as an argument since we can't modify the original immutable object like that. But because of the fact that we are reassigning it, yeah, whenever this gets called, every time this function gets called, it will run this global sequence, which will basically now refer to the new updated version of the C1 apply counter whenever we loaded it in as the change attribute list dot C1 apply counter. Okay, so I got that figured out. So we can actually do this from client, but we need to do it in the context of in the namespace. Like, we would have to, we can save it as C1 apply counter, but when we load it in, we're gonna have to say change attribute list dot C1 apply counter. So let's just, I think the best way to do this is basically to just go through this list just like we did with this one, and we're just gonna write like what I just said, like how to save it and how to load it. So we're gonna say how to save this namespace is fine, and then how to load, I guess we can leave it on one line like this, and we'll say how to save this namespace is fine, how to load, and that is going to be different, obviously. To load it, we have to do it in the namespace of changed attribute list dot C1 apply counter. Yeah. There we go. Okay. So next one, it's going to be the same thing because it's just the C2 version. Now, for C1 expect counter, this is different because this is coming from client. It's not coming from change attribute list. So we're going to go over here to client, and let's see if we can find the from change attribute list, more C1 change attribute list, C2 change attribute list. We're looking for apply counter. So let's do C1 apply counter. That's the one we're looking for, right? No, we're looking for expect counter. Sorry. Let's fix that. Let's see. So C1 expect counter is equal to 1. So this is a non-transferred adder. We said we needed to save this though, and I'm assuming that the reasoning was correct. So C1 expect counter equals 1 to start, and then we check it here in the main while loop. This is during the apply section, and it checks the current client. So it does have to be saved in the context of the current client, not the other client. So I think we would do it just like that under that namespace. we would just have to make sure that current client is already a thing when we do that. But I mean, technically we could check the, well, we would have to check the ID of the current client. I know that we get the client ID like the first thing whenever we connect to a game. So that's one of the first things that's saved. So whenever we reconnect, that should be readily available. So we would just have to load that ID in first, and then either we would assign current client first, or we would like just use the ID and say C1 client or client 1 or whatever. But I actually need to know that. I can't just like move forward until I know whether we should load it as current client.c1 expect counter or as like C1 client or whatever the. Let's see, where does that happen? That happens in setup, right? So let's open up setup. Setup ends up creating or instantiating rather the two clients. Is that true? No, it doesn't. Where does that happen at? It doesn't happen in client, which is strange. I thought that's where it happened. Or maybe it does, because here's the class. Okay, I see. We do it. Oh, so there's only one. We just end up calling client current client, because we do refer to other client, apparently, at some point. So we have the instantiation of client here. So there you go. There's that. So we can just say client, because this is going to happen like when we run the client file. This is going to happen before we actually can execute any code. This is going to happen at like this is going to be the first thing that happens at runtime. Therefore we don't have to worry about like not being able to use that namespace. So that should be the way that we do it. We're just going to say client dot. Let me see here, because at some point client turns into current client. And I just want to make sure there's no way that client would end up referring to like other client. Okay, so it's right here. Right here it says current client equals client. So it always will refer. It's synonymous. Like it's the same thing. So yeah, we can do it like that. So let's go over here, and we're gonna save it in terms of. The same space is fine. No, this, yeah, we can save it as that, and then how to load. Well, I do wonder, should we save it with the like name attached to it? You know, like should we save it as this string? I feel like that makes more sense. You know, man, I gotta say, never ceased to I'm always surprised by people. Always surprised. Alright, so this should be client dot. So we have client.c1 apply counter. And yeah, we're just gonna have one namespace. and that is how it's going to be saved, and that's how it's going to be loaded. I think that's the smartest way to do this. So like we don't have two different things, we just have the one, which is called so in this case it would be C1 expect counter. So this would actually be just client.C1 expect counter. And it doesn't really matter if we said client or current client because they're literally the same thing. I'm pretty certain they are. Like we just looked at that where it's, let's see, client equal, or rather current client equals client. Yeah, so there's only one, and that happens at the earliest stages of the game. But okay, so this section right here, this is the outer while loop. This is for whenever they're choosing whether they're going to start a new game or reconnect to a game. So technically, when they choose to reconnect to a game, that is when we would do the loading in of the data, right? So if they select reconnect to game right here, then it's going to go down here, and we're going to get the client ID from the database, the game ID, all this stuff from the database, and then we just basically load that in, and the first thing we do is set current client equal to client. So it really doesn't matter. Like we could do either or. Yeah, so this current client is client. So at like once we did this reconnect to game, the first thing we would do like after this would be to call that load function, which is like what these notes right here are associated with, where we would have the actual the load from database sequence happen to load in all the data for a reconnect. But long story short, we can just say client dot, and that's how we will load it, and that is also how we will save it. So they're exactly like the same. So we have the change attribute list C2 apply counter, change attribute list C1 apply counter. So we have this. One, two, three, four. And these got fudged up because of me adding the prefix to them. So this is going to be the same. We're going to do client.c2 expect counter. Then we have C1 to C1 received data storage dictionary. I would say this is probably going to be the same thing, but I just want to be diligent and make sure of that. I don't want to assume. Never assume anything, ever, when you're programming. Okay, so this is an attribute just like the expect counter is. Yeah, so yeah, we would do it in the like the namespace would be client.c1 to c1 receive data storage stick, just like the client C1 expect counter, C2 expect counter is. So it's going to be the same thing here. So we can just paste that for these four because they're all going to be the same thing. And then we have the received cal tuplist. Let's check this out here. So we have this receive cal tuplist. It also is a client attribute, so it's the same thing. Alright, so we have the card group name dictionary, and this is associated with custom append list. But how exactly do we... Okay, so this is actually a class attribute. This is not an instance attribute, so this is a little bit different. This is merely a placeholder assignment. It is reassigned to proper custom append list instance dict vals in setup. But we did add this to the save list, so we must have determined that it does need to be saved, like, I guess after setup is run. So I probably need to, like, put that, like, make sure that this happens after setup is run. So how do we, like, how do we do that? We would say, do we just say custom append list with the camel case like this? But from the client file though, can we do it like that? You know what I mean? We don't... I don't know if we actually import custom append list. Let's see. Okay, so we do actually. We import custom append list. So in that case, yeah, we would just literally say that we could just do this namespace custom append list dot, but it would have to be run after setup, and setup gets run somewhere here, right? Okay, it does. It gets run. Okay, yeah, this is perfect. That's like right before we were going to load in the data, right before the main while loop starts. Okay, so that's great. So I will just put a note though that it needs to be saved after the running of setup, because setup does modify it. What does setup set it to? Well, it's going to end up setting it to... It's going to end up setting it to this, which is required in that context. So we can't like remove this or whatever, and we're not gonna make it conditional. We're just gonna overwrite it immediately after setup. So we'll just put a note here. So this would actually be loaded in as custom append list dot card group name dict. Now this one is going to be, we need to have a note that says ensure this is loaded after setup is run in client Pi upon reconnect, aka load from DB must happen after setup, which was already going to be like the case most likely. So okay, next one is going to be deck. Let's see what we got going on here. So this the instance is called master deck lowercase. So we have master deck dot. So that's how we should be doing that, right? I think so. And I want to say this would have to be run after setup as well, because setup creates these lists as custom append list instances. Yeah, because they're initially set to placeholder regular lists, and then when setup gets run, they are basically recreated as custom append list instances. I don't see deck though. There it is. Okay, so master deck, master deck, discard piles, custom append list, instance. Yeah. So this is the same scenario. We would need to have this run after setup. So let's do discard pile. Okay. So this is going to be called master deck, and it's lowercase, right? Yeah, master deck dot deck, and then we have this one's going to be master deck dot discard pile. So we can change this to be such and such. Now, card group dictionary handles XY display layer. So this one's a little bit special. This one, whenever we load it, it's gonna have to handle the XY and display layer. We're not just gonna like straight up assign this. And also, this is gonna be saved in skeleton form. So it's gonna have to be converted to. It's gonna have to be converted from a list of integers into a list of actual cards. So that's another thing we need to account for. Also needs to be converted from skeleton format to card format upon load, which means logic must be added for this. Right, so this is going to be same for this one, like this. Alright, cool. What the fuck did I just do? There we go. Alright, so we have message at discard pile, deck pile, blah 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 blah. Card group dict. Yeah, so this is gonna be in skeleton format as well, right? Do we already have the logic for saving this? I don't think we do. Stable save state function. Then we have the update load state save state. Okay, so we didn't actually finish that. For name in self master save object list, if a card group. Okay, so we created the skeleton. Well, we created pseudocode for this function. I thought we actually finished this. I didn't. Like I didn't realize we didn't finish this. It's okay though, because we needed to finish this list first. Like that had to be done first, because it determines like how this is gonna work. Because this iteration depends on what's inside of the save object list. So obviously we're not gonna create logic for like stuff that doesn't exist. Yeah. So anyway, let's go ahead and we'll just go back up to the top where we were and continue working on that list. We'll come back to all that later. We just have to, like, you know, we'll reference these comments here. So we have also needs to be converted from skeleton format to card format upon load. Logic must be added for this. Same thing for discard pile. And this is also going to be the case for the card group dictionary, right? I think so. So say below line. Also, this will just be changed to needs to be converted from skeleton format to card format upon load. Logic must be added for this because it's going to just be a list or a dictionary. Well, when we iterate through the card group dict. Okay, so there's two different things that need to happen. Whenever we save it, let me put it in this format. We'll say upon load needs to be converted from skeleton format to card format. And then we'll say upon save. Upon save needs to be converted from card format to skeleton format. And same for this one. Actually, I'm wrong. This needs to be here. Sorry, here we say upon load, upon save needs to be converted from skeleton format to card format, and then upon save, and we'll put save first because save is what happens first. So save from skeleton, from card to skeleton, load from skeleton to card, save, yeah, card to skeleton, and then load will convert skeleton to card. And then we have the card group dictionary, which has to be converted. So this is going to be the same thing here. Just add that. Upon save needs to be converted from card format, and then upon load, yeah, and we just put below line for each one. There we go. Predict XY song num. Okay, so what? How do we save this? Because this is one of those that would only need to be saved in the context of like current game. So as long as current game exists, then we could just use that namespace. But this one actually has to handle the XY display layer. So how does this work exactly? Whenever we save the card group data, the card group dictionary is, I thought it was just a mapping with a key and a value, and the key was the ID and the value was the card object. I think that's how it works. So we're using the card group dictionary like as to do multiple things. Not only are we going to use it to since we're iterating through it already, to save each card, well, you know what? Technically, we don't really need to save the card group dict as like a mapping from integer to card, because we can't actually save the card object, because the card object is a Pygame object, and Pygame objects cannot be serialized. So what we do, or what we're going to do, is we're going to have to convert the dictionary upon saving to a dictionary that, instead of mapping the ID to the card object, it's going to map the ID to basically like a tuple of 3 data points, and that would be that card's X, that card's Y, and that card's display layer. So yeah, card group dict would have to be converted. So it's going to be converted from card format to skeleton format. And let me just put like details on that. Instead of saving ID to card object, we will be saving ID to card.x, card.y, card.display layer, just in a form of a tuple. So it's going to be a little bit extra logic, but nothing complicated at all. stuff I've done like 100 times in this project. So upon say needs to be converted from card discuss more about legend will be added for this. So saving ID card object, we'll be saving ID card display layer. That makes sense. And then so on loading, we'd have to, instead of loading load convert, or would you say upon load convert from this to that. Okay, so we do need, well, we already have the ID because the ID is the key. Well, yeah, we already have the ID, so the ID is the key. So how do we map the, like, how do we, first we would have to map each ID, we'd have to map each ID to each card object, and that would have to be done through iteration of the master deck, right? Isn't that how we do that? I think that's typically how we do it. It has to be done in the same way that it's done normally, and I'm quite certain that is through. So we create the double deck. It has it's always in the same like order, the cards, that is. And then we, okay, well actually we shuffle the deck. We create a copy of the deck, and then that's when we map each card to an associated ID. Okay, so I'm realizing here, I mean, it's not really a big deal, but it would be it would probably be smarter to map the card. Like, it would probably make more sense to make it go in the order of from 1 to 108, and the first card, basically mapping it before we shuffle it, so that there's always, like, the card with ID 1 will always be whatever the first card that gets created, and that would be like what, you know, the 2 of hearts, and then ID number 2 would always be, you know, the 2 of diamonds or whatever. So in that way, it would just make like logging and debugging easier if we did have to deal with the cards, because we could look at the ID and I would basically be able to like know, oh, okay, I know what we're dealing with here. Like if it's a 10, it's gonna be like way up high in the ID number. If it's a 2, it's gonna be like one of the first 4 cards. So it's the ID is gonna either be 1, 2, 3, or 4. It's probably more to have this executed in context, create double deck or create card. Yeah, and I think that's basically what I was getting at with this comment. We're gonna say needs to be mapped prior to shuffle, because this will allow ease of remembering or identifying card objects during debugging in logs via their IDs. Yeah, i.e. 2 of hearts will always be ID number 1 or whatever. That makes sense. Okay, so let's go back over here. So technically, though, it doesn't really matter how we do that. Like it doesn't actually matter. So if convert from ID card blah 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 blah. It doesn't really matter what ID gets mapped to which card. Well, wait, actually it does, right? Yeah. Because then we would just basically be randomizing, like, we would we'd be randomizing what cards go where, because that's how we that's how we move the cards around, right? Is through the card group dictionary mapping. So we actually would have to have the same mapping that we had last time, which means we would have to make it to where they get mapped prior to shuffle. So I'll add that as well. Also has to be mapped prior, because we have to be able to have an exact mirror map when we load the card group dictionary and reassign their associated IDs. If we don't, then we can't. If we don't, then we can't what? Well, we would be like mixing up the cards locations. I'm pretty sure that would mess up the cards locations on the screen. You would be putting a randomized set of cards in the previous locations, but like the card, it could be any card. Instead of the 2 of heart being in your hand, it would just be like the 7 of club, like, because it's random. And that's bad. We want it to be exactly how it was, right? So I think we have to do this for it to work. So I'm gonna put a note here. Convert. We'll say for this to work, must change code in setup so that the well, hold up. Let me think about this. Yeah, that would randomize it. Yeah. It would have to be. It would have to be mapped. The ID would have to be mapped to the same card every time in setup, because setup gets rerun prior to loading. So that means in the initial connection, setup is going to run, the deck's going to get shuffled, then we're going to map ID to each card, and then when we disconnect and reconnect, it's going to reshuffle the deck, and then it's going to map that new set of it's going to be a completely different organization of the cards, and map the ID. Just, it's going to be random at that point. So then whenever we went to run this code to assign that card ID, the card associated with that ID's XY display layer, it would be handling the wrong card. So yeah, we must change code in setup so that the mapping of ID to card object happens prior to this work must change code in setup so that the mapping of ID to card object happens prior to shuffle. Duh. There we go. And we also need to this is when we would load it, we would be setting the card's XY display layer, right? Isn't that how it would work? So we're loading in the card group dictionary. We have this card group dict, which we're gonna say is at this point in the database a dictionary with IDs as the key and a tuple as the value. What we have to do is we have to convert that to a new card group dictionary consisting of the ID to the card object, which that would require iteration through the master deck dot deck. Isn't that what it's called? Master deck dot deck lowercase. Yeah, so the master for current card and master deck dot deck. So it's lowercase d. Requires iteration through the master deck dot deck. Oh shit! I'm crashing here. Crashing, dude. Getting a little sleepy. Like, not sleepy per se, but like, I don't really want to be sitting here. We got 10 minutes left. All right, let's power through this. All right, requires iteration to the master deck. Then what else? So we convert from blah blah blah. It requires iteration to the master deck, and then we need to. Then we need to iterate through the master deck.deck and so iterate through the master deck.deck. So we would iterate through the master deck.deck and do two things at the same time. For each card, we would add it to say per iteration, and then we would do assign each card an ID and add to the card group dict, right? Yeah. And then we would also have to assign each card's .x, .y, .display layer. Yeah, assign each card's XY display layer. I think so. Yeah, assign each card an ID to add to the card group to assign each card's XY display layer. Yep. Yeah, so we're killing two birds with one stone there. So that was probably the most complicated one. And the last question for this one is, what namespace do we refer to it in? This one would be current game, right? As long as current game exists. So we need to say current game equals, where does that happen at? So it happens in client, and this is whenever they reconnect. So this would be prior to the loading, which means we would be able to use that namespace. So we could just say current game dot card group dict, right? Because it is a game attribute, correct? Let's open up game here. And let's see. Is it a which one are we looking for? The card group dictionary. This might actually be a class attribute. Okay, it is. It is a class attribute. So it is independent of each instance. It is assigned. Yeah, it is a class attribute, so that does matter. Well, it doesn't actually matter, but like usually if it's a class attribute, I assign it in terms of the class name because that just is proper. Let's see. A dict that is going to be populated with all the card objects, and where does it? It gets reassigned in setup. Well, we append to it. Card group dict. Yeah, we append to it inside of. Let's see, setup game card group dict. Yeah, right there. So in setup, we add to it. We just looked at that code, and setup does happen prior to load. So we refer to it in terms of game.G. So that's how we'll want to refer to it. So let's do it like that. We'll say game.cardGroupDict. Alright, moving on to the next one. We have song num. So let's look that up. And this is going to be this is another class attribute. Yes, I think. Yep. Yeah, it's a class attribute. Wait. No, am I tripping? Yeah, it is. Yeah, it's a class attribute. So we would say game.G. Game.G. And is there anything special about this, like when this needs to happen? Well, it gets assigned here upon the creation of the game class. So that's like that will happen before we load in any data, and then it is modified inside of event handler. So yeah, loading it in to whatever it was after this point, but before this point, would cause it to work correctly, right? I think so. Yeah, so we're good. We don't have to we don't have to worry about special logic. It's just straight up like easy. Alright, next one is going to be choose multiple cards. This is actually a property, right? So we have choose multiple cards. Is it transferred game matter, but what kind? Is it? It's in the time tube. Choose multiple cards. This is game calc property. So this one is an instance property, which is, as like functionally speaking, it's an instance. Is it an instance attribute? Where is this? Oh, it's in game. I'm looking in the wrong file, doofus. Looking in the wrong file, doofus. So time, choose one of the cards. Blah, 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 blah. So, yeah, so it is a. It is a instance property, aka instance attribute. So this would be current game dot choose multiple cards. So we say current. Whoa, what happened? Current game dot choose multiple cards. But it's a big but here. Do we need special logic for this one? Um, I don't think we do. I don't think we need. I think this is just one of those where, well, it gets set upon instantiation, and then nothing happens until like we get to a point in the game where they need to choose multiple cards. So it would be basically just yeah, current game, choose multiple cards. It would just be straightforward. Nothing complicated about that one. We would just assign it straight up, and it should be good to go. Yes. Cool. Okay, so we're going to stop there because we're actually basically done. I'm going to put the note here. So it's going to be 5, 16, 25, stopped here. So let's go ahead and copy this. Now we're going to go over here to, this is line 51 in save logic. So let's add that right here. We're going to say stopped at line number 51 in save logic.py. And so we have 522 to 628. And this is a continued going. We're going to say continue going through save logic. Let me just copy this. There we go. Save logic master save object list determining final form of namespace for object name, and also including final pass pseudocode / comments for proper save load logic for each object, for each data point. Boom. Yeah, there we go. Alright, so now we're gonna copy this, put it right there. This is gonna be 6 29 to 6 30. Now 6:30. That puts us at 1 hour and 8 minutes, so we'll just say 1 hour, and we continue finalizing save logic py save load logic, same thing. Yep. All right, there we go. Now we can copy this, go over here, ensure we're in the root of the project directory, which we are. Project / Canasta, get branch, check right branch. We are on the feature branch, so we can git add to stage our everything. Now we can do git commit -m double quotes, paste in that devlog. There we go. We did our we made our commit successfully. Now we can do git push to push up to the cloud to fucking GitHub, and yeah, that's done. Now we can close this shit out. Move over here. I hate IOBit. Don't ever use IOBit. We'll go over to programming projects. We'll change this to be 516. Enter into Canasta. We're gonna copy that bad boy, go into the backup, delete the old one, and paste in the new one. So now we have a new local backup just in case fucking Iran nukes the GitHub servers. And now we have to check, and that looks good. All right, so we're done. Good progress, great project progress. Very happy. Almost done with this. Oh, I'm so ready to be done. And we're really close now. We are like in the final stretch of this feature, and it feels so good to be almost done. What we have to do is just finish going through that list. We're like, what, a quarter of the way through it, a third of the way through it, and just figuring out how we have to save it, load it, and then once we finish going through the list, we have to actually like finish that save function, which iterates through that list and actually saves the data to the database using the logic that we put in the comments in the list, for how to save it properly. Some of it has to be converted into skeleton format, integer, etc., and then we have to do the exact same thing, but for the load function, which is going to load that data in. It's going to iterate through the list, or it's going to iterate through the database. It's basically the same thing, and use the comments that we put in that list for how to properly load it. Once we finish the save function, then the load function, what we have to do then is just call that save function at a certain point in the client script and figure out exactly where we're going to put it. It's just going to be one line where that function gets called, and then the same thing is going to happen for the load function. We have to figure out exactly where we're going to put that function call, and then we have to test it. So very close. I would say probably one more session, maybe 2 more sessions to finish up that list, and then probably another session to finish the save function, and then maybe 1 or 2 more sessions to do the load function, and then another one to test. So that's what, 1, 2, 3, 4. That's like 4 or 5 more sessions. So we're looking at about 6 hours of work roughly to be done with this feature, which is pretty good. And then we just have to test it. So hope you guys have a good day.